Hey everyone.
Hello, everyone,
Hi
and welcome
Sarah.
to this show. Yeah. Hi,
Yeah.
Charles. How are you
Hi.
doing?
Fine and you?
I'm good, thank you.
Okay. It's welcome to our first episode. I hope everything works. Uh, it's the first episode, so please be indulgent. We never know. We will improve over time, I hope. So thank you for joining this first episode of our new series on policy engines. Let's introduce ourselves quickly before we start. I let Sarah introduce herself first, and I will introduce myself after.
Yeah, sure. So, hi, everyone, and thank you for joining us on this new series on policy management. I'm Sarah, a platform engineer with background on software development. I am working on since few years now on topics around Kubernetes building platforms with Kubernetes ecosystem. And yeah, happy to be here all today and co-host this show with Charles Edouard. So yeah, you can go, Charles Edouard.
Yes. So I'm Charles Edouard. I'm a software engineer. I've been doing software engineering for about 20 years now. And yeah, I got interest in the policy management scope. And therefore, Sarah and I are close friends from a long time. So this project is the opportunity to introduce the fans community. It's just a personal initiative from Sarah and I that we've been working on in our free time. Um, our mission is to dive deep into the world of policy engines. We aim to understand and promote various policy related tools in a totally unbiased way. So we believe that different tools have unique strengths and are suited to different use cases. So we want to help people find the best solution for their needs. And yeah, I think Sarah has something to
Yeah,
say.
yeah, we are also writing technical blog post articles, but today we are trying to experiment this new form, and interactive form, through this series of live stream. In each episode, we will focus on one policy management related project, and will be also joined by guests who will be able to present their projects in different aspects. Here is the general idea of this, how this series or these episodes will go, and what you can expect from this episodes. We will first start by learning more about the guests, and then dive into the details of the project. We'll also enjoy a practical demo from our guests, and we'll give also time at the end, or maybe also in an interactive way. We'll give the chance to the audience to ask questions, and we'll pick them and ask them later on the side to our guests. So please be patient with us, because this is our first episode, as Charles said, and please help us with your feedback to improve it, and yeah, make this show great.
Thank you, Sarah. So, with that said, we have the chance today to have Flavio Castelli as a guest. Flavio Castelli is a maintainer of the Kubewarden project, and we will take this opportunity to discuss with him the Kubewarden project. So, Flavio, welcome.
Hi everybody. Thanks
Th-
for the chance to be here. Really happy to be here with you.
Yeah, we are quite excited to have you, and thank you for joining. So, maybe to start the discussion, could you please introduce yourself to the audience and tell us more about you?
Yeah, sure. So I'm a distinguished engineer at SUSE. I work inside of the Rancher division. My main focus area is Kubernetes, where I spend some time dealing with security related topics. And I'm also looking and actively contributing into the WebAssembly ecosystem, or at least trying to. There's so much movement going on over there.
Okay. What was your professional background? Mostly software engineering? Did you work on the infrastructure side of things? What got you interested in Kubernetes, containerization, and things like this?
Mm-hmm. So I've always been on the software engineering side of the house. I started doing different things at SUSE. Well, actually today is my anniversary at SUSE. It's a pure coincidence. It's 16 years over I've been spent at SUSE. So
Congratulations.
Congratulations.
yeah.
I would
So-
say happy birthday.
Yeah, thanks. So I was doing many things, mostly in the backend space, and well, I assisted to the dawn of Docker. So I saw a potential in Docker for simplifying some aspects of the delivery of applications. I was working back then inside of an application that was hosted by SUSE. So we had a live system with many nodes, and we were going through this phase of keeping all the nodes in sync with software like it was Chef back then. And then Docker came along and I said maybe this can help us in some way. And so that's how I got involved with Docker. I'm one of the ones, one of the people that brought Docker at SUSE. I started to work in this space, and then, yeah, as you know, it's not just one single host. You need to orchestrate containers across many hosts, and it seems like ages ago, because now Kubernetes is the de facto standard for orchestrating containers, but back then it was not. So we had to make a decision about which orchestration solution we should have supported and offer to our customers and guide them through these difficult times where there was a lot of doubts. Which one should I pick between Mesos, now gone, Docker's Worm, gone, Nomad, really nice, but we've never kicked off outside of certain circles, and then Kubernetes. So we made the right decision, and so I started to deal with Kubernetes as provide a distribution of Kubernetes together with other people, build a Kubernetes offering to our customers. So picking the different components, which back then it was again a lot of bets. Which CNI should I pick, which Ingress should I pick, and there was everything moving so fast. It was interesting, and then I was always interested about the security aspects. First with just containers. So how do containers work? How to make them more secure, and then how to keep also Kubernetes secure. And this is how I ended up also looking into the policy engines.
Okay. Thank you for those details.
Great. So we discovered this project, this amazing project, a few weeks ago. I think back down to KCD Italy, if I am not mistaken. And we also released recently an article about the project, and we were curious to learn more about it, and we would like to. I think the audience also is curious to hear the story behind this project, how this project started, and what was or were the motivations behind creating this new policy engine. And also, could you please give us also a bit of context how you end up working on this project, on policy management in general? What interests you in this field?
Yeah, so basically, for a long time, I've always been answering. There were customers coming and asking questions about how, for example, can I do multi-tenancy inside of Kubernetes, in a not in a strong way, because strong isolation, strong multi-tenancy inside of Kubernetes is hard. But where I would refer to it as soft multi-tenancy, like you have some amount of trust about the different workloads that they are scheduled on the cluster, but still you want to isolate them. And so one of the ingredients to this solution was the usage of admission controllers to validate the incoming objects, to maybe modify some of them to reflect some choices by the system administrator. And back then I always said, yes, you have to use it, and just go on and use Gatekeeper, which back then was the main solution available. And I looked into Gatekeeper and I played a bit with it, but not too much. And then one day I had to actually, I wanted to get my hands dirty with it. And I started, writing policies for it to just try to implement some of the things that I was suggesting to some customer or to some colleague to do for our own infra. And that's when I realized that I wasn't super happy, to be honest, with Gatekeeper. That's a matter of personal taste again. Everybody has different tastes, and coming from a software engineer backend, I know different programming languages. It's not hard for me to learn something. I like to learn new things, but learning Rego was not so pleasant to me, and and that's what was causing me to struggle with that. And then someone inside of the company challenged me and said, would it be nice, to come up with something that allows you to write policies in a different way, which is not so prescriptive, doesn't force you into doing that. And then I started to think about that, and then there was the opportunity to work on something new. I had some spare time back then, and so I picked up this topic again, and I started thinking about how to do that, and so I thought maybe we could use this WebAssembly thing that I always read about, but I always dismissed as being, this is a browser thing. And as I said, I'm a backend guy. I'm not interested in I can do HTML, but yeah, it's not my cup of tea. And so let's see if this can work, and started prototyping stuff around. It was 2020, and together with another colleague, Rafael Fernando Lopez, we started to write what then became Kubewarden, and that's how it started.
So it started as a side project?
Yeah. Yes.
Under the SUSE umbrella, under your own initiative, or?
Yeah, it was, so I have a certain amount of freedom over there, so, and I was able to, to invest some time, working our time on that topic, and then, I kind of made a, let's say, business case, but it's too it's too fluffy as a term, but I showed them, look, there is this thing, so this is the current state of the ecosystem. We think we can do something different from a different angle, which could be better. And so this is a working prototype. Let's invest some more time in that and see how it goes. And that's how everything started. It was open source since the beginning on GitHub. It was created by us at SUSE under Rancher. And then we donated the project later on to CNCF. Now is inside of Sandbox. And we would like to move to the next level, to incubation. This is something we would like to do this year. And so, yeah.
Okay, so now the project is part of the CNCF. Benefits all the CNCF ecosystem, I think. Did you go to comment ça s'appelle, the big conference,
KubeCon and
KubeCon.
this one.
Yeah.
I mean, it was interesting timing because due to it was 2020, so there was COVID and all the conferences were done in a remote fashion. And suddenly there was no travel budget limits. Awesome. I mean, I can apply to any kind of conference and just deliver it from home. I don't have to convince anybody to travel around the world. It's bad, of course, but on the other hand, it was good. And honestly, WebAssembly was coming up strongly because we were one of the first adopters really of WebAssembly outside of the desktop, and there is still some hype, quite some hype around WebAssembly. And so thanks to that, we landed different talks at different conferences, different KubeCon events, different WASMs day conferences, security dev conference, container days. It was really crazy. For a bunch of years, it has been really crazy. We had many talks. Now, one of the things that I personally struggle about is after having delivered so many talks, I found annoying to come up with the same thing again. So I always try to put things from a different angle. And honestly, I just kind of brain exhausted. At one point, I didn't know what else to pick up as topics. So we are still delivering talks. And as Sarah said, some 1 month ago, there was Kubernetes Community Days Italy, where I was there. I missed you, Sarah. I'm sorry. I
No worries.
over there. So
I remembered you. Yeah.
Oh, thanks.
You will not miss her anymore.
Yes, definitely.
Next time you meet with Sarah.
Yeah.
Great. Did you come in Paris?
No, I didn't. There was a colleague of mine, however, over there. Also, being part of CNCF, we get booths. There is always a rush of different CNCF projects to get a booth inside of KubeCon. We managed to land a space over there, like for a community project. Otherwise, when we didn't get it, we always have someone at the Rancher booth talking about that. It's an open source project, and in case someone wants to use it outside of Rancher, this is totally doable. So we try to be around, and there are also other people now working on it, and so I'm the creator one together with Rafa, but I don't want also to be like the only one talking about that.
You are
here today. Sorry.
You are based in Italy?
I'm based in Italy. Yes.
Okay,
working close to Milan.
Yeah, working remotely, or do you have a SUSE office?
We have some offices, but we are all pretty spread across Italy. So I've been working remotely since I joined. I happen to have some colleagues that are not working on Kubewarden, but are working on other topics that live in my place. Actually, I made referrals to a good friend who then brought another one, and so now there is even a small group of SUSE employees in my hometown because of that. So, but yeah, I'm doing that remotely. Yeah.
You built a little group.
Yeah, great. So I guess that since SUSE is adopting, or like this project has been created under the SUSE umbrella, I guess that it is used everywhere in your platforms, and you have real case, like production use cases. Could you tell us a bit more about this?
Yeah, sure. So, well, generally speaking, for policy engines, the main drivers are security and compliance. So, security to prevent possibly exploitable containers from entering into the cluster. So, one of the main drivers for adoption has been the replacement of PSPs. Because a lot of people were using PSPs and they got deprecated, now they're dropped. And while PSA exists and it does a good job, PSA, which is bundled inside of Kubernetes, is not a one-to-one replacement of PSPs. It doesn't cover all the cases of PSPs. Plus PSPs, some of them were also due a mutation, which is not something that PSA does. And so one of the main drivers for starting to use a policy engine is I need to find an alternative to PSPs. PSA is not enough for me, so what do you have for me? So that's one thing. Other things that you can do, for example, are with all the different supply chain attacks that happened during the last years, there is the topic about trusting the software, the workloads that you're running on your cluster. And so we go back to the topic of image verification, for example. So you sign your images with, for example, Sigstore, with cosign from Sigstore, and then you want to enforce all the workloads running inside of your cluster to be using images that have been signed by someone you trust. There are many people that, for example, also do things like I take an image that I vet because I inspected it, and then I sign that with a bunch of keys of my platform engineers, and then only the images that have been signed by at least 5 out of my 10 platform engineers are allowed to run. So that limits, for example, certain types of attacks. And then it's not just about containers, because there are also other types of resources inside of Kubernetes that you want to keep secure. And so, for example, I don't know, finding leaked secrets maybe inside of config maps, so making sure that someone by mistake is not like pasting a token for AWS or for whatever inside of the config map. And then there is the topic of compliance. So there are different criteria that organizations have, like I want to have certain labels set so I can do accounting better, or I want to make sure, for example, that when an ingress is created, this is not going to overlap with other ingresses that are already there, and many different interesting and crazy, in a nice way, and crazy things. So people like to come up with a lot of different rules, and that's nice.
Yeah, every company will have different requirements. So Kubewarden allows authoring the policies you need for your personal use case.
Yes, exactly. Yeah.
Maybe that's a nice opportunity to present the project in more depth. And eventually, if you have, I don't know, an architecture diagram or something that can help us understand better how Kubewarden works from a high-level overview, it would be great. And maybe you can tell us a bit more practically how Kubewarden works, how we can install it, what will be deployed, the different components, and how potentially to create a policy, deploy it, make sure that this policy does what it is supposed to do, things like this.
Yeah, sure. So first of all, the key point, probably the main differentiator of Kubewarden is, as I said before, it is using WebAssembly. But what does it mean? Why that? So the thing is, our policies are basically can be written using different programming languages. So you can pick the best language for you depending on your knowledge, your skills, or pick the best language to address a certain specific problem. That means you can write a policy, for example, in Go, in Rust, and because maybe you already have knowledge. And while doing that, what you can do is you can leverage the whole ecosystem of this programming language. Also in Rego you can do that, yes. So we support programming languages, and with programming languages I mean like Turing complete languages, so Go, Rust, and then we also support kind of DSL. So Rego is supported as well, so you can reuse Rigo policies that you wrote for Gatekeeper or for this strange admission controller that is not Gatekeeper that uses Rigo, and you can just use them without doing any change to them. We also recently introduced support for writing policies using Cell, which is Common Expression Language, which is something that is a new feature inside of Kubernetes. And the nice thing is that here you can basically take a Kubernetes validating admission policy and just copy and paste that and run it inside of Kubewarden if you want to. The talk I gave at Kubernetes Community Days Italy showed that and explained why you might be interested to do that, and I can go into that if you want later on. And what else? Also, there is some level of support of Kyverno, but just for some specific cases, like again, copy and paste Kyverno policies. And that's because this is maybe too deep, but basically a policy is just a bunch of code that is run by our policy server. The policy server, you can imagine that as kind of a platform as a service that is running policies. These policies are WebAssembly modules, which you can see them as plugins. So like with, I don't know if you're a Linux user, well, but like with GIMP, for example, image editor, you need to add a new effect, or with Firefox, you need to add a new extension, a new add-on. You basically add a plugin, and this is how we grow in terms of capability and features the policy server by adding these plugins that are built with WebAssembly. And these plugins are then distributed using container registries. So these are stored inside of the registries as OCI artifacts, and they're pulled down by us. I can show you, I'm mentioning a bunch of things, and you wanted to have an architecture diagram. So also, at any time, feel free to interrupt me if something is not clear or if you want to go deeper into something.
I think it's pretty clear. We are already discussing how maybe we can put that full screen.
I didn't prepare a slide about that. I just wanted to reuse and also as an kind of an excuse also point out to the existing documentation. So this is the Kubewarden documentation that lives under docs.kubewarden.io. You can go in there and search like architecture, and you will find this page, all right?
Okay.
So the way it works is, of course, we are inside of Kubernetes, and so we have a bunch of custom resource definitions that are used to define our policies. We have two types of custom resource definition. One is called cluster admission policy, and these are described also in the documentation over there. A cluster admission policy is a policy that can be enforced across the entire cluster inside of all the namespaces, and is also a policy that can be used to validate or to mutate cluster-wide resources like a namespace itself. If you want to do validation against namespaces, this is a cluster-wide resource, of course, so you have to use a cluster admission policy.
Okay, but it's not limited to cluster-wide resources, right?
No, it's not. It's not.
Okay.
So if you want, for example, to say I don't want to run privileged pods inside the entire cluster, you can define a cluster admission policy that is targeting pods, and this is able to look into all the namespaces of a cluster.
Okay.
The other one is, and this is this is the most powerful type of policy you have. Let's keep in mind that policies can be really dangerous because if they stop to behave, or if they are created by an attacker, they can be used to maybe exfiltrate secrets, like confidential data, including secrets, or they can be used to mutate things in an evil way. So this is something, the cluster admission policy, that should be created only by the platform engineers, and with the proper RBAC rules, you can limit that to the right set of people. The other
Okay.
policy is, the other type of custom resource we have is admission policy, which is instead a namespace policy. So this is something that you can give the RBAC privileges to other people to manage their own admission policies. These admission policies, they cannot target cluster-wide resources, and they are basically always constrained to the resources that are defined inside of a namespace where the policy is enforced. So if you want to have a team deal with its own compliance rules, like for labels or whatever, and you as a platform engineer, you don't want to be bothered by that, you can tell them, yeah, you can create your own admission policy inside of the namespaces that you own and just do the validation you want, and that's it. So
it will impact only your namespace.
Exactly. Only the namespace where this is created.
Yeah, it won't have any side effect on other namespaces where the policy doesn't exist and things like this.
Yes. I will show that to you later on inside of the demo, but yes.
Okay, that's very clear.
And so these custom resources are then reconciled by this Kubewarden controller over there, which is a controller running inside of a cluster. And as with all the different policy engines for Kubernetes, we are all leveraging the dynamic admission controller. So we are creating validation and mutation webhooks for that. And the controller takes care of creating the proper configuration and then pointing, the API server to the policy server, which is another resource that is hosting the policy. So that introduces the last custom resource definition we have, which is policy server. The policy server is where the policies are run, where they are actually run. It's a web server that exposes different endpoints, one endpoint per policy that is hosting. And this is what the Kubernetes API server is reaching out to do the validation or the mutation to have a response. The policy server is then implemented using a deployment which has its own replica size. So you can say I have and you can have multiple policy servers defined. So for example, you can say I have a set of critical policies that have to be always available. All right, so I will create a policy server called critical with a replica size of 5 with different toleration tains and resource constraints. And then I will schedule the critical policies when on these policy server. When you define inside of a CRD of a cluster admission policy or the admission policy, you can say this policy has to be run on top of a critical policy server. And this is going to run over there. And then if you have like a noisy tenant, for example, noisy because it makes a lot of requests, you can maybe isolate these policies over there by creating another policy server. You're not forced to do that. This is something you can do. And we have some adopters of Kubewarden that are taking advantage of this architecture to isolate certain types of policies because maybe they are more, as I said, critical, they are more compute intense. They must have a lower latency. So this is something you can do. It's up to you.
That's very interesting. Can you say a policy should run on different policy servers, or do you have to create separate policies, one per policy server?
So a policy is scheduled just on one policy server.
Okay.
So you have to be explicit about where this is going to be run. If you do not specify anything, it will run on a policy server that is called default that we create as part of the installation. But on one policy server, you can host all the policies you want. So you can have like 10 policies hosted on the default policy server. That's totally fine. And then, of course, the policy server is just a custom resource. And then you have a deployment, which is going to create n instances of pods of this policy server that is hosting this policy. So you can have 10 pods running policy server, and each one of them is hosting the same set of policies, and the requests are load balanced across them.
Okay.
Great. Okay.
So to summarize, if you start with an empty cluster, you install Kubewarden, it will spin up the Kubewarden controller, it will install one or more policy servers, the two main components of the project. Then the Kubewarden controller will start watching policies. It will configure the admission webhooks and mutating webhooks to execute policies every time a resource is created, updated, deleted, whatever.
It will instruct Kubernetes to reach out to the policy server that is hosting the policy. So we take care of keeping and sync the validating webhook configuration, for example, and pointing that to the service that is exposing the policy server that runs the policy.
Okay. Great.
I can show to you again. This is the quick start where we explain what to do, and so we have a Helm chart. The first one is the Helm chart that installs the different custom resource definitions that we have.
Okay.
And then you install the controller. Once you are done with that, at this point, you have a controller that is trying to reconcile policies that are maybe created by the user, but there is no policy server defined yet. And that's fine, because maybe you want to create your own policy server, which is not the default one. But basically, everybody moves then to this step where we create a policy server called default. And if depending on there is a flag, there is a value inside of the Helm chart that, for example, allows you to not just define the default policy server, but also deploy a set of recommended policies. And by doing that, you end up having a cluster with a bunch of things running. I can show that to you now or later if you want. I mean, screen sharing.
Yeah. Just one question on my side. As a platform engineer, I have to ask, what is the operational complexity or added by Kubewarden in the platform, for example, side?
So the moving parts to monitor are, the controller for sure, that you have to make sure that it is reconciling the resources. And then you have the policy server instances. So if something goes wrong, the first thing to do is to look into the policy server and see what is happening over there. So we have integrations with Prometheus. So you can have alerts and dashboards. We also provide some default ones that you can use to have a grasp of what is happening inside of a cluster, like how many rejections are happening, what is the policy that is doing the most rejection, this sort of stuff. And then we have an integration with OpenTelemetry. And so, for example, you can configure, we have documentation about that, you can configure the policy servers to send trace events to something like Jaeger. And then what is really nice is that you can go into Jaeger and figure out why a policy is rejecting something. And the nice thing is that this is something that applies to every type of policy, because we try to make, to us, the language used to write the policy, Go, Rust, Go, Cell, whatever, should not matter. Everything is operated always in the same way. It behaves in the same way. So for the platform engineer, it doesn't matter how the policy author created the policy, you always operate it in the same way. But it's also true that when you're writing a policy, for example, with a programming language, we have a way to also provide really detailed trace events. And so you can like when you are debugging a microservice and you can see all the span of events, you can also drill down really deep into the validation or mutation project and see what are the different steps that happened and what was the output from them and what got in, what got out, and that helps you debugging things
Great.
when stuff goes south.
Okay. And I also that you are integrated with you can use a policy reporter also to report.
Yes, exactly. So this is another thing. So we have this audit scanner process, which is running at a tunable interval time. And this is basically looking into what are the policies that are defined inside of a cluster, what are the resources that are, let's say, under observation by these policies, and then for each one of these resources, we figure out is it compliant and is it not, and we create a policy report, which is this, it's a custom resource definition that is being standardized. It was created by the Kyverno people, and there is work inside of the policy working group. Is that correct? To standardize that. So we are generating that, and there is a UI, an open source project called Policy Reporter. Is that the name?
Yeah, it's called Policy Reporter, developed by Frank, German guy. Yeah.
And so you can use that to obtain also information about what is compliant and what is not compliant inside of your cluster, and the reason why it is not compliant.
We should invite Frank in one of the live streams at some point. He did an amazing job, I think. Policy Reporter can send metrics to Prometheus. He can do a lot of things. It's mostly used for the UI part, but it's really a tool that can do so much things. I wish we can have Frank one day.
We may maybe have to try to invite him here for Charlotte for the next episodes.
Maybe we can ask him if he wants to join. And yeah, I know Falco is using Policy Reporter. Kyverno is using Policy Reporter. Kubewarden is using it too. I think Trivi uses any project using the Policy Report CRD can be used with the Policy Reporter project. So it's really great to see how this project benefits from the standardization of the policy report resource.
Yeah.
Okay, so maybe it's a good time to jump into the demo if you want to do that.
Yeah,
and
sure.
From what I understand, a policy is made of different things. There is the definition of the resource the policy is targeting, because we cannot infer that from the WebAssembly. It has to be defined separately, right?
No. So, I mean, when you... So, I will show that to you. So, another thing which is which I wanted to point out is that the policies that can also be reused. So, there are, companies that have their own specific things, but if I want to replace PSPs, of course everybody wants to replace PSPs, and so we can reuse these policies. And so what I wanted to show to you today is, if you go to Artifact App, over there is a section about Kubewarden, to browse all the packages, and you can find all the Kubewarden policies that have been shared over there. And so when you are writing, when you enforce a policy, you have to, inside of a cluster, you have to say this is a policy that is interested about pods, for example, and it could be mistaken by the operator what the policy is targeting. So this information, what the policy targets, what kind of operation it targets, this is actually inside of a WebAssembly. So we are enriching the WebAssembly file with some metadata the policy author actually is doing that. And in order to publish a policy, we also require this metadata to be there, so that we can do some fancy thing, which I'm going to show to you. So for example, let's say that I want to have a policy that put constraints on labels. Like I don't want to have certain labels enforced, so there is a policy ready to be used for that. You go there and you see the description of it. If you want to play with this policy, one thing you can do is, instead of deploying it straight to Kubernetes, you can run it outside of Kubernetes. As you can see here, you see there is a command that we can copy and paste called kwctl pool. kwctl is a CLI tool which mimics the syntax of Docker. So you have Docker pool, you have kwctl pool, you have Docker run, kwctl run, and so on.
Okay.
So the purpose is, like we did for the developers, to allow them to reuse their knowledge. We do the very same thing also with operators, so that they can reuse their own knowledge. So, for example, I can do kwctl policies, and I can see a list of all the policies that I have downloaded on my machine, all right, where they are coming. Policies most of the times are hosted on container registries, which is the most common scenario. But if you want, you can also fetch it from an HTTPS server or from local file system. But these are, the local file system is handy when doing local development, but for production usage, everybody uses registries. And here you can see that we already show some information about this policy. This is coming from the metadata, like this is a policy that does mutation, this is a policy that does not do mutation, and then we have this column about context aware, which is policies that at runtime they need to access information from the cluster. Like I was saying before, the typical example is I want to validate ingress objects that are being created, so that there is no overlap between the ingress object that is about to be created and other ingress objects that are already inside of the cluster. So in this case, the policy has to know what are the other ingress objects inside of the cluster. This is what we call being context aware. The context is the Kubernetes system. And so here you know if a policy is context aware or not. And
Okay.
there are some other things and differences that Kubewarden takes on that compared to, for example, Gatekeeper. If you want, we can talk about that.
But for example,
Yeah.
we don't know the type the policy targets. If it's a policy for pods, for config maps, for ingresses, or any kind of policy.
So this is something that here you don't see that, all right? But this is shown later. So the next step I do is I pull the policy, all right, so that I have it on my local machine. Now this is fetching it from the registry. And then if I list the policies again, I can see that now I have two versions of a policy because they are all tagged like container images. And I see that I have it now. If I want to know more about what this policy is about, I can use the inspect command, all right?
All right.
And here, inside of the inspect command, I get access to all the metadata that is defined inside of a policy. So again, like is done with container images, where you have a set of standardized labels that you use to enrich a container image with metadata. We are reusing the same set of labels, plus we introduced a bunch of not labels, they're called annotation inside of the OCI spec, sorry. A bunch of annotations that provide more information. And here you can see that, for example, this is a policy that given any kind of object inside of Kubernetes as labels, it can target everything, all right? So here you have a star. But if that was a policy targeting pods, you would have seen like v1 pods create update. So this is how you know what a policy is doing. And also you have access to the documentation of a policy, because that could change across different versions of a policy. Maybe v1 did something, and v2 is doing other things. And you can see, this is provided by the user, so they can, by the author, they can say how to configure that and yada yada. So
Okay.
Yeah.
now, if I want to try out the policy, first of all, I need something to validate, and this is something that, for example, we can put inside of a CI system. I can have a bunch of Kubernetes object resource definitions. All right. So what we and then try to run the policy against them. So this is an ingress definition. All right. What we have to do now is to generate an admission request of type create. All right. And the object that is being created is inside of this file. And so we run this command, and then we can see what is the generated object. So this is basically what Kubernetes sends to a dynamic admission controller, to a dynamic admission webhook to validate. You can see a bunch of things that, as a user, I probably don't want to know, but the important thing is in there I have my object, and that's it. So now I have an object I can use to try out the policy. Now I want to test the policy. So a policy can have some configuration parameters. In this case, for example, the policy has a configuration parameter called mandatory label. So we want the cost center label to be defined inside of the resource. And we also want the cost center label to satisfy this regular expression. All right. And so we do a run. These are the settings that now are defined here, but if you want, you can read them from a JSON file on the hard drive. This is the request that we created over there. This is the policy to run, and yeah, let's run it. So this is running now, and this is the response I get from the policy. So as you can see here, this ingress, it had the constraint, the label that we were requiring. The label value is matching the regular expression, and so this is allowed. So what you can do, for example, is to do some automation around that inside of a CI system, and write assertions to do that. This is something that is useful, not really to the policy author, because the policy author, when writing the policy and testing it, he can test it in this way, but I mean, he's writing a policy using some programming language. And so, for example, he can use the testing facilities of his own programming language. So he can write, like if you're writing in Go, he would be running a Go test for it. So like he would do for his production code, which is way faster and way more flexible. This is more for an end user, like an operator. I want to figure out if this set of parameters applied to this resource is working as I expect. So they can do some automation. One area where we would like to have some feedback is do you as a user envision a different way to drive that? Would you like to drive it in a more not in a bash way, like because then you can, the way people do it is they run it with bats. I don't know if you know bats, for example, to write test cases with bats that are basically running bat and making JQ assertions. But I don't know, it's a matter of personal taste. So and
Okay.
and then what we can do is we can also run it again. And now we are requiring not only the cost center label to be defined, but also the owner label to be defined. And the object that we are evaluating doesn't have it. And so as you can see now, allowed is false. And you get a rejection message coming from the policy. Here, my choice of colors is not good. So you cannot see these fields, but if the policy can also set some annotations, some warnings. In this case, the policy is not setting them, so everything is null. And now I tried it out a bunch of times. I'm confident about this tuning of a policy, and I want to deploy that inside of a cluster. So what I do now is I can scaffold the definition of one of the Kubewarden custom resources. In this case, I'm going to create an admission policy, all right? And the manifest is taking exactly the same parameters as run. So you can just do arrow up and replace run with scaffold manifest. Everything stays the same, all right? And what you have now is is this YAML that you can take, tune it, or just pipe it into kubectl apply, and then deploy your policy. And yeah.
Okay. And at this point, we have the API groups, API versions, resources defined inside the admission policy itself.
Yes, exactly. If, for example, I don't want, this is really a special case because, again, it's a policy that can target everything. But if I want to constrain it, I can go into save this file and change it manually and say, okay, I'm going to target only V1 pods, for example, and this is it. But if you're fine with that, you can just deploy that in the cluster, which would be the next demo. But if you want to ask more things or comments.
Yeah, because basically you can reuse the same policy with different types.
Yes.
You can say this is a policy that requires this and this label, but I want to apply it only to secrets or ingresses, or you're not forced to apply the policy to every resources. So the policies comes with some suggestions in the image annotations, if I understand correctly.
Yes.
But at the end of the day, you decide the target types.
Yeah, exactly. You can also decide, this is something that we just introduced with before that. You can also define, for example, some, at the end, there is a lot of filtering that can be done also by the Kubernetes API server. You can put namespace selectors, object selectors, and so you can, we are exposing these fields. We're not showing them here right now, but you can also say not only this is targeting, for example, just secrets, but you can also have an object selector statement that forces down to secrets with a certain key.
Okay, yeah. And there's even match conditions now, I think, that you can embed cell expressions.
Exactly, and we can do that as well. So you can embed cell expressions and basically write a cell expression that decides when this webhook, when this policy is going to be invoked.
Yeah, okay. Of course, it doesn't work in all Kubernetes versions.
Yes. But, well, just graduate it, so a bunch of versions and everybody will have it.
Yeah, sure. I hope so.
Great. So I think we are over the 1 hour that we, but
time flies.
It's exactly. Since it's an informal discussion, we can maybe, I don't know, Shahrizad can maybe continue with this stream.
Yeah, sure. Maybe not too long, but I think the demo was great, and I think it showcased quite some features of Kubewarden. And yeah, I see we have a question. Maybe we can show it on the screen and take the opportunity to ask Flavio to answer the question.
So the question is, do we need cluster level access? So to define cluster admission policies, you have to have a proper set of rights in order to create them. and then the policies are basically running with a service account that is the Kubewarden policy server one that you can tune, and the service account is taking is used only when you have a policy that fetches information from Kubernetes. So what you can do is when you are deploying a policy that fetches information from Kubernetes, you operator, you must say what kind of resources is this policy allowed to access. Because, for example, there could be a policy that says, I'm just looking into pods, but then behind the scene, because it was done by an evil policy user, is also looking for secrets, and then maybe doing something with that. So we basically constrain the visibility of the Kubernetes resources to the policy based on what the administrator wants this policy to have access to. And on top of that, there is also a way to, there is the kind of visibility that the service account is granted. So it doesn't matter if I say this policy can look into Kubewirt virtual machines if the service account running the policy doesn't have access to Kubewirt virtual machines. I hope that answered the question. If not, just keep writing and I will do my best.
Maybe to install Kubewarden, we need cluster level access.
Oh yes, that's.
I don't know if it was the question, but you have to create CRDs, and those are cluster level resources.
Yeah.
Thank you, Dinesh. The next question is from me, actually. So the question is there a way to not block an admission request even if the resource being admitted violates the rule, but to somehow track the violations in a report, in an event, or separately?
Yes. So each policy, so inside of the cluster admission policy and inside of the admission policy CRDs, there is a field that defines how the policy operates. By default, it is put into enforce mode. So if there is a violation, it blocks the violation. But you can put that into the other mode, which is monitor mode. And in this mode, a violation is not blocked, but we emit events and leave traces so that you can understand what is going on. Usually it's used to learn how a policy would impact your cluster without breaking disruption since the beginning, because you have too many non-compliant things in there.
Yeah, that's usually a good way to start with policy. Not blocking first, fixing the violations, then you can start blocking. But starting with enforcing the policy can result in an outage or something not working anymore.
Yeah.
Okay,
great.
I have also one last question for you, maybe Flavio. I would like to go back to the WebAssembly topic. I'm impressed with the work done by you adopting this WebAssembly approach of dealing with policies. But I would like to know also what are maybe the disadvantages of using WebAssembly, and what are the maybe the complexity that WebAssembly brings in this context.
Yeah. So well, it's WebAssembly is an evolving space. So when you take there are many programming languages that support WebAssembly, but the level of support they have is different, and so not all of them are working as smoothly. So for example, if you were to write with Go, we suggest you to use TinyGo, which is another compiler, so you have a better experience. the fact of using WebAssembly is also leading to, then you have this binary blob that you have to distribute. Sure, you distribute that with container registries. You can use all the usual tooling also to sign and verify that, like cosign verify, cosign sign. But of course, there is this extra step. And when it comes to policies written using programming languages, it means that if you want to write a new policy using a programming language, this is something that it takes some, we have templates that you can use to scaffold things, but still is not as with Rego, with Gatekeeper, where you go and you just write inside of a CRD some text and it runs. However, with a cell policy, for example, or the Kubewarden policy, we could even do that with a Rego policy if people ask us to do. What we allow you is to basically type the program, type the policy inside of a CRD itself. So there is no need to compile something, to push it somewhere. You just have to fetch one policy, which is kind of the policy engine for cell, the policy engine for Kubewarden, and if people want, we are open to suggestion, the policy engine for Rego itself. And so that kind of limit, the problem, let's say.
Okay. So what are your plans for the future in this case?
What we are currently working on is the ability to join policies together. So, for example, there are some people who say, I want to have the verify image signatures policy, but it has to be applied only when there is this extra condition to happen. Like if the request came from a certain user, all right? So now with the self-validation put in there, we could do that, but let's assume that this option is not there, it doesn't exist. So in the past, what you would have to do is to take the policy that does the verification of images and add some new code logic, some new business logic in there to implement this check. And many of these checks that can be reused across policies. So what we are working on is to introduce the concept of groups of policies together. So this is going to be a new CRD where you mention a bunch of policies and then you can combine them together with Boolean operators, which is basically like writing a cell expression. Actually, we are mimicking cell or using cell. So you can say verify signature and also run this other policy. And this is something that would allow more composability of policies together.
Okay.
I think I have one last question, and maybe after that we can conclude the live. And we can conclude eventually with a few words about your roadmap and what are the features being working on these days. I know you just released a new version, so it's probably time to get some rest.
There's no rest.
No rest. Okay.
No, I mean, so we do monthly releases. That's what we try to do. The roadmap is all public. If you go to the Kubewarden GitHub organization and look into our project board, you will see there is one project board with a roadmap, another one with the items that we are currently working on. We just released 1.15 last week, or maybe this Monday. I'm a bit fuzzy because I just came back from vacation. The team did that while I was away. And so what to expect on the next release, aside from what I just said, we are also going to remove the dependency on Cert Manager, which is something that people asked. And we are also going to, while doing that, to improve our posture when it comes to certificate rotations inside of the cluster, certificate for the different components and the internal root CA that we use. So this is something that is a big step forward. And keep working on fixes and other things.
Yeah, and I think it was not my question, so I will ask my question now. Then we can go to the conclusion after. My question was, from what I understand, Kubewarden leverages programming languages mostly to write policies. So in this context, what would be the recommended best practices to test a policy? Is this recommended to adopt a sort of traditional approach related to development, like writing unit tests and things like this? Or do you recommend using a tool, something dedicated to policy testing actually?
So when writing a policy as a policy author, my recommendation would be to use the testing approach that you would use when writing a program in that language.
Okay.
If you were writing a policy with Rigo, for example, I would recommend you to keep writing tests using Rigo, using OPA tests, for example. That would work pretty well. For consumers of policies, what I recommend is to use KWCTR run, like I was showing before in the demo, and then write some assertions around that. There are many tools. I was mentioning bats to do that. There is another one I personally like, which is Venom from OVH, that allows you to write assertions. But if you are into bash scripting, you can even do that with bash scripting and with the things you want. So this is what I would do. It depends on the persona, basically.
Okay. As a policy author, you should write unit tests as with any piece of software. And if you are a policy user, you have KWCTL or anything else, but you have a solution as a user to do that too.
Yes.
Okay, very clear. So maybe we can give you the opportunity to tell us the last conclusion and to let us know what Kubewarden needs to grow today. How the audience can start contributing, engage with the project, or anything that would benefit Kubewarden in the end.
Yeah, thanks a lot for the opportunity. So, well, it depends on, there are different kinds of contributions. So contribution to the documentation, for example, would be good. Even just pointing out this section of the documentation is not clear, or asking for new topics to be covered by the documentation. If you don't know how to do something, just reach out and we can work together at writing this portion of the documentation. It would also be great to have more policies. So if you are making your own policies, don't be shy and share them on Artifact Hub. Everybody can do that and just enrich the Kubewarden ecosystem. And of course, if you want to get more down into the code base, we would like to have contributions over there. So in any case, you can reach out to us on Slack. So there is a Kubewarden channel on the Kubernetes Slack server. There is also a Kubewarden dev channel where most developer-related topics happen. So you can join both of them. And also we have monthly community meetings. You can find the schedule and the link to join them on kubewarden.io. Just show up and tell us about what are the things you're struggling with. Generally speaking, I want to use a policy engine to address this problem. And let's talk about that and share your stories with us. Feedback is a powerful way to grow the project, and we're looking for that.
Okay, great. Good. Thank you so much, Flavio, for being with us today here in this show. I'm sorry for holding you for more than 1 hour.
No, it's not a problem. It was
and
a
also, thank you for helping us with the review of the article. And we will leave you the link to the article in the description of this show. And yeah, maybe Charlotte, you want also to say something?
Well, I think you covered almost everything. I want to say thank you, Flavio, for being our guest, our first guest. So it's probably not as smooth being the first, but it's great. Someone has to start. It was you.
You were amazing. You were amazing.
You did really an amazing job, great presentation, great demo, and I hope everyone that watched the live stream or will look at the replay will learn a lot from the Kubewarden project. So thank you for that, and see you for the next episode.
Yeah, thank you. See you
Thank
guys.
you. Bye
See
bye.
you. Bye bye.
Bye.
Bye. Thanks.